ready. So hi everybody. I would like to welcome you to our short session on cutting-edge performance in quantum technology, an inside look at Baden-Württemberg and the UK. We have 30 minutes prepared for you, and these are 30 minutes full of information, and they will provide you a deep dive into the quantum technology ecosystems in Baden-Württemberg and in the UK as well. And you will discover all the strengths the two ecosystems have and the collaboration potential they offer. First of all, I would just give you a short introduction to who Baden-Württemberg International is. We are the location promotion agency of Baden-Württemberg. We promote Baden-Württemberg as a location for science, research, business. We support Baden-Württemberg enterprises and higher education institutions and research institutions to internationalize. And we do support investors as a one-stop agency to come to Baden-Württemberg. We organize these sessions together with UK Business and Trade. And we are happy that we have the possibility. We would like to thank UK Department for Business and Trade for this opportunity. And UK Department for Business and Trade is a similar institution to Baden-Württemberg International. They offer similar services just for people who would like to come and settle in the UK. We are here present at the booth over there, where you see the big the yellow roll-up, and therefore you can meet afterwards my colleagues from BVW, and you can meet the colleagues from UK Department of Business and Trade for network and further information afterwards. And now I'm looking forward for my panel with two great experts on the ecosystems of quantum technology. To my left, to my very left, it's Professor Dr. Kai Bongs. He's the director of the DLR Institute of Quantum Technology and professor at Ulm University. He is physicist by training. He studied and worked in the UK for a long time. And far more to the left, you find Stephen Holmes. He's quantum investment specialist at UK Department for Business and Trade. He worked in IT. He has experience as a founder of a high-tech company, and currently is working on his PhD on, as I looked up in his LinkedIn profile, post-quantum cryptography. Wow, it's a difficult word to pronounce for me. So now we would like to start with question one, and I would like to ask you two, what is the biggest achievement in quantum technology in Baden-Württemberg or the UK so far? So who would like to start?
Oh, you want me to start? Okay, let's see if that... Can you hear me? Okay, now we go. So I should say I only arrived in Baden-Württemberg in April, so I'm still new to it. Okay. But I was... first of all, very, very impressed by the openness and the engagement of companies with quantum technology. So I think a big achievement is that really the culture of engagement has been created in Baden-Württemberg. And that might be a bit soft in terms of the terms. It's very, very important, but there's an openness and interest in this innovation and interest in where it goes. If I go a bit more specific, one big area is, of course, Diamond NV, where Baden-Württemberg has created a lot of science, a lot of applied devices, and now has quite a few companies, like one of which has just won the Quantum Effects Prize, Envision, which is certainly a big success, having cancer treatment improvements in the next few years coming from quantum technologies. So I think we can really see with these companies something is coming which benefits all of our lives. And around that, like QAnt, the Bosch startup, all of them work with Diamond NV. There are companies like Diatope who come in, do the materials. So there's a whole ecosystem around Diamond NV, from the material to the, or at least processing of the material to the applications. But I think that's also a big opportunity to work with the UK, who has like the leading material supplier in diamond material, like Element 6. So maybe I'll hand over.
Thanks. I think that the thing that's interesting about this is in the UK, we started this journey in terms of building the quantum ecosystem 10 years ago. So we published a roadmap for building that ecosystem 10 years ago. In April this year, March, April, we actually announced the next 10-year plan. And with £2.5 billion worth of support over the next 10 years, the key thing is we've now got a fairly mature ecosystem. And when we're talking about disruptive technologies, they require government support. And that's not just about money, but it's also about having the skilled resources to actually develop the technology. Now, in the UK, we've actually created, if you like, 4 hubs, which actually are starting to really deliver some cutting-edge performance. Only last week it was announced that we had the hub, the communications hub based in York. They'd actually got a photonic quantum-safe link between Belfast and the UK, which is 420 kilometers. So that's the longest photonic quantum-secured link in the world. We also are starting to see a lot of activity, specifically as Kai was saying, with the key components here, whether it be the NV diamonds or whether it be other areas around the ecosystem to develop both quantum computing, but also looking at quantum sensing and looking at quantum algorithms. So the UK really has built up a series of 4 hubs covering these 4 areas, and we're starting to see some significant new announcements pretty much every week. But it was kind of interesting last week that I saw the announcement from Quantinuum and Stuttgart University about stabilizing qubits. So there is a lot of interaction between Baden-Württemberg and the UK ecosystem, and we think that actually just builds a stronger ecosystem. So I think in terms of the actual performance, we see the performance is really going to be enhanced by having that ecosystem, and addressing perhaps one of the biggest challenges we have as an industry worldwide is having enough quantum information specialists. And that's where I think we see a lot of strength in the UK and in Germany.
Okay, so if I got you right, in both ecosystems we find a whole value chain from science to technology transfer to products. We do have specialists, we have training institutes for the specialists in both countries. So are there strengths in both countries which might be complementary, so they offer potential for cooperation? Would like...
Okay, I can give it a start again. So I think I already mentioned element 6 as like materials. I think the UK, indeed, lots of skills where like one can have exchanges. The UK is also very strong in like standards, I think, which one needs to look at, while Baden-Württemberg, on my view, has a lot of engineering strengths. So if you really if you look at companies like Bosch to be able to scale up MEMS production, for instance, make things cheap, large-scale production, that is, I think, where some of the engineering companies in Baden-Württemberg have a real the skill set to help once you're beyond single prototypes. So how to get a large
to scale it up.
Mass, how to scale it up, and I think that's one of the next steps coming.
Yeah, I think that's actually an interesting, if you like, difference between the UK and the German ecosystem. I think in the UK we have over 320 startup quantum companies right now, and pretty much the largest number of quantum startups in Europe, and investment in those. But one of the things that we focus on is really supporting those startups, but also when we look at the application of the technology, I think where Baden-Württemberg and Germany has a significant advantage is actually directly applying that technology to corporate enterprises, whereas traditionally in the UK it will go through a range of different enterprises. But I think that is something that is good for collaboration, because the other thing that we got to remember here is it's still a disruptive technology, and what that means is we don't actually know the final state of the technology and the use cases for it. So what we need is these early customers to actually help shape the actual requirements and what we can actually do with the capabilities of this. So a good example of that really is the UK government recently announced a £15 million competition for quantum companies to actually propose quantum solutions to government problems. And there were a number of companies that responded to that, but that actually gives support to these companies with actual revenue and also giving them information that helps them develop a product. It's one of the challenges that we see is that the whole of the ecosystem is still, the technology is still not mature. It's maturing, and it's maturing quickly, and the performance is growing every week, but it's something that does need government support in order to be able to productize, and as you mentioned earlier, it's about taking it from the concept in the lab to really be able to deliver it as a solid value-added solution to business. And that is also an area of innovation that really is essential, because you need to not just have the technology innovation, but the business innovation as well.
If I may just add to that, I think this is a very important point, that while quantum is now quite advanced and you have a lot of spin-off startups with first products coming, the challenge both of us still have is to get the market rolling, so that we're now at the point where there are products, but the market is not yet accelerated as much as the productization. So we need to push on the applications and see that we get the whole ecosystem moving, because the benefits can be enormous, but we need to educate the people who actually employ the quantum technologies. And I think there are some areas where the UK and Baden-Württemberg, they're both very strong in aerospace, for instance, where one could look for like joint applications in the future and how to develop these ecosystems into the markets.
So which kind of support would you like to have just to develop the market? What would be useful for the companies, for the people doing the technology transfer?
So if I can answer that, I think the challenge we have with any new disruptive technology is you have innovators that will buy the technology, but it's a fairly small market. You need to then get to the early majority who really are going to look at this and see some business advantage. The problem you have with any new disruptive technology is that initially the performance of it is less than you actually have with traditional technology, but it improves rapidly over time. And once it crosses over, it's like a hockey stick, then the business benefit is there. But then you've got to convince your customers to buy this, that it really is something that will actually aid their business and provide value. And that's essentially where early funding and early support from government can help, because we can be an early customer in order to support these fledgling companies, in order to give them revenue, and perhaps more importantly, it gives you references, and it actually is able to provide a case study to show how you actually benefit the business with a business value. And I think that's a very important role for government, to be able to support these companies as you're building a new disruptive, not just disruptive technology, but a new marketplace.
Okay. I think, yes, I entirely agree with that. I think what we really need is like schemes which allow sort of educated customers to try out the quantum technology. So you need not just, essentially you need people to come in to say, okay, I have a problem like the water companies, I have a problem of 10% of fresh water in the world is getting lost by leaks. Can we use some quantum sensors? Let's do some trials to find out. Can we essentially use these to help with that problem? And essentially with that demonstration create a market. Or if we take all the medical technologies being developed, like Envision for cancer therapy or Circa in the UK for like magnetoencephalography, we now need work for clinical trials to get it into like the normal clinical systems, so that becomes a routine treatment instead of a research topic. So we need to make this transition from, oh, that's an interesting thing, to, yes, this becomes like day-to-day work.
Yeah, something which is daily used, yes.
And so we need, in principle, funding for the applied researchers in companies and who are actually not quantum, but use quantum technologies to try what can they do with them.
Yeah, I get it, yeah.
I think you raise an interesting point also, is that, with this new disruptive technology, you get new ways you can use it, which we've never had before. So the use cases are very different. And the danger is you compare it against an existing technology. So one of the more amusing analogies I've heard was really when the Wright brothers had the first flight of the Kitty Hawk, the performance was compared against the horse. And the horse won, because the horse was far better at actually getting to places than the Kitty Hawk. But we know the history, it's completely different. The thing that I really want to emphasize here is that it's going to have a different set of metrics for the capability than what you have today. So yes, measure it against something you can measure today, but also think about that there are new things that you can do with this technology that you can't do with the existing technology. So I think that's important to be able to quantify, measure, and articulate in terms of a business use case and a business value. And that's part of the discovery process as you have early customers to be able to tease that out and get references. So I think that's important to support these companies.
Stephen, I'm sorry, I have to interrupt you. My colleague is getting nervous because we have some use cases waiting to show up.
Perfect.
We have pitches of British enterprises. Right now they are waiting I think we leave the floor to them. So thank you very much. It was an interesting discussion. Thanks a lot.
Yeah, thank you for having us.
Good afternoon. Right, so I believe there's going to be a few pitches now from some of the companies in the UK. And we're Quark Technologies. And yeah, quantum technology is offering to revolutionize the way the technology that underpins our modern society works. Computing, sensing, and communications, these are some of the areas that looks to change the most based on quantum technology. Out of these, Quark sits to take a center position on sensing. Now, that for us means enabling better precision timing, navigation, and positioning. It means more robust telecommunication in case GNSS goes down. And it means doing things like monitoring gravity over larger areas for a longer time to observe changes in what's going on. But for us, it's critical that this technology leaves the lab. It needs to come down in size, weight, power, and cost. And that's what we have set out to do. What enables us to do this is our knowledge in vacuum fabrication and microfabrication. But what makes us special is the way we trap and cool atoms. What we do is we break with the methods of the last 25 years. We don't use any magnetic fields, which means we're able to make systems that are far more small, compact, cheap, and robust. And that means that we're no longer talking about the idea of taking cold atom and quantum technology out of the lab. We're actually doing this. And this is something from a trial we did last year, actually. And we're now talking about how we're going to use the technology by doing actual field trials. This is in timing, this is in gravity right now. But actually, we're looking to expand that. And so if you'd like to work with the next version of cold atoms, or if you'd like to explore how quantum sensing with cold atoms could give you the edge, collaborate with us, or join us on the journey, then please come have a chat afterwards. So my name is Alex Jansen. This is Quark Technologies, where matter makes waves.
The World Economic Forum estimates that there will be over 30 billion devices connected worldwide by 2025. In our increasingly connected and digitized world, data security and cybersecurity is becoming increasingly important. Currently, any sorts of data, whether they are sensitive personal data, government data, or company data, are secured by encryption protocols which depend on a random number generator to make the encryption keys. However, existing solutions are failing for two reasons. So first, they are software-based solutions called pseudo-random number generators, which are vulnerable to bias and brute force attacks, or they are hardware-based classical true random number generators, which are vulnerable to attacks on our hardware and are also limited in terms of generation rate. At Quantum Dice, we leverage the fundamentally probabilistic nature of quantum mechanics to offer a true random number generator with a patented protocol developed at the University of Oxford called Source Device Independent Self-Certification. It's able to, in real time, monitor and also react to any changes on the hardware device to ensure that for our customers, they can be guaranteed of both the minimum quality and also quantity of true random numbers coming from this system at any point in time. Currently, we are venture capital backed, a team of 19 based in Oxford in the United Kingdom, and we have 3 different products available. So we have a rack mount device, Apex, at the top, that's used by a classical network security developer as the source of external and trusted encryption keys. We also have a 2.66 gigabit per second Vertex PCIe card, and this is used by telecommunication network operators and trying to provide an on-demand trusted key generation service. We're also currently working on a space-suitable product, and if you're interested in learning more about quantum dice or any opportunities for collaboration, then please do reach out to me.
Hello, I hope you can hear me okay. Perfect. So yeah, I'm really excited to present OQC to you today. My name is Ines Juvan-Beaulieu. I'm a partnership specialist at OQC. And in the next 2 minutes, I'm going to tell you a bit about who it is, who we are, what it is we're doing, and how we do it. So Oxford Quantum Circuits was founded in 2017. We're a spin-out from the University of Oxford. And we really started with a patent. So that was the CoexMon patent, and that is how we build our quantum computing processors. So it's all based on the CoexMon IP. We're based on superconducting circuits. And what do we offer is actually quantum compute as a service. What does that mean? It means that you don't need to have your own system in your office or your lab. We provide access to our quantum computing device, and we do so by providing 3 different access options. So we have a private cloud access, public cloud access, and also in the next months, we're going to roll out our direct access options, which means because we're in a data center, so our customers that are in a data center can directly connect to our quantum computing device and have access. So this year, it's going to be really busy for us. In the next 3 months, we're going to deploy 3 new systems, so they're all from the same next generation. It's a 32-qubit device called Toshiko. We're going to deploy Toshiko in 3 different locations, one in the Sixtera data center in the UK, one in the Equinix data center in Japan, and one in a supercomputing center in Sesca in Spain. That is a collaboration with Fujitsu. So you can imagine it's a very busy year for us, but really with demonstrating that we're co-locating together with data centers means that we're bringing quantum computing out of the lab. So I mentioned the CoexMon patent before, so this is really how we build our QPUs. It's our proprietary solution, and what is essentially different is that it's a 2-dimensional architecture. So if you compare it to a 2-dimensional chip like, for example, Google has, we have a 3-dimensional chip, which means we're bringing key componentry off chip. So that means all the control wiring, there's actually also no hard wiring between the chip and the control wires. There's a vacuum, and that really allows us to deploy and build scalable and flexible systems with very low crosstalk. So yeah, that was about OQC. If you have any other questions, feel free to meet me afterwards, or you can find my extremely long email address at the bottom. Thank you.
Good afternoon, ladies and gentlemen. This event is all about the capabilities of quantum computers, that they can solve previously unsolvable mathematical problems. Unfortunately, they can also solve the mathematical problems which are the core of today's cryptography and break it. This means that digital signatures, digital contracts, emails, bank accounts, medical records, company secrets can be read, changed, and faked. Malicious software can be deployed looking fully like legit updates. Any devices, cars, company networks, production plants, and critical infrastructure can be corrupted, halted, damaged. 8 years ago, an international project for developing and standardizing a new class of cryptography algorithms that are immune against quantum computer attacks has been started. These new algorithms, known as quantum-safe cryptography or post-quantum cryptography, have already been selected. The draft standard has been released and will be finalized next year. PQ Shield is Europe's leading vendor of these new crypto algorithms in software for all kinds of computers or in hardware to be integrated in computer chips. They don't run on quantum computers. They run on today's classic computers, simply replacing today's now weak cryptography and protecting against quantum computer attacks. They will soon be legally mandated worldwide, but anyone who exchanges data or documents that still will be sensitive in 10 years will need to act as soon as possible, as the data could be copied now and decrypted later with a quantum computer. And anyone building devices that still run in 10 years should make them already quantum safe or upgradable to become quantum safe. I am Burkhard Joule. I'm with PQ Shield. Meet me either in the networking area or at booth 2A41 and learn how to upgrade your systems to be quantum safe. Thank you.
We'll go to the next one. Oh, I need to click. There we go. Ooh. There we go, folks. Hello, everyone. My name is Yuri Anderson. I'm the CEO and one of the co-founders of Angoka. So Angoka is an IoT cybersecurity company. You heard previously one of the speakers mention that will be lots of connected devices in our smart cities, and that's absolutely true. Everything from connected infrastructure to next generation mobility, whether they be connected autonomous vehicles or whether they be drones, for example, all of them will be communicating over public networks. And that means, of course, with a quantum threat on the horizon, that we need to secure that communication. Our approach here is something that we've developed alongside BT and others, which is a product we call Q-Link. And what it does, it uses QKD as a quantum root of trust, and then we package those quantum keys that we generate through QKD and then distribute that out to the endpoint devices. And we can do that without compromising any of the information theoretical properties of QKD. So it's a very, very strong way of getting those keys out to the endpoint devices. And this is how we secure the communication for the future of all of our connected devices. Thank you.
So, thank you, everybody. We are already coming to a close. Our 30 minutes are over. Thanks for being here. You will find the companies at the booth of the land over there for further discussion, and my colleagues of BVW also for further discussion if you are interested in coming to Baden-Württemberg. So thanks a lot to everybody. Have a good day. Good afternoon.